Our speaker tonight is Kirk Bertsche, and he will be addressing whether radiometric dating can be trusted. Dr. Bertsche earned his PhD from the University of California at Berkeley in physics, where he worked on the design of a new instrument for radiometric dating. He also has an MA in exegetical theology from Western Seminary, where he assisted Professor James Sawyer in teaching on the relationship of science and faith. Dr. Bertsche is a Bible teacher at Grace Bible Chapel in San Jose, an RTB volunteer apologist, and an officer in this chapter. Please join me in welcoming Kirk Bertsche.
Can we trust radioisotope dating? That's the topic for tonight. And as you see here, archaeologists will date any old thing. So want to look at basic principles of radioisotope dating, and then look at two examples, radiocarbon and potassium argon, and then a brief summary. So atoms, as you know, are the basic building block of matter. Atoms are made up of a big cloud of electrons. That's the black fuzz here. And those surround a nucleus in the center, which is very small. The electrons are negatively charged. The nucleus has a positive charge. It's made up of protons, which are positive charge, and neutrons. And the Z of the atom, we use the letter Z to refer to the atomic number, and that's the number of protons. That determines which chemical element it is. And then the number N is the number of neutrons, and you add those together, you have the atomic mass. So you can have an atom like carbon, and to be carbon, it has to have 6 protons. So Z is 6 for carbon. And it can have 6 neutrons, 7 neutrons, or 8 neutrons and still be carbon. That would be carbon 12, carbon 13, carbon 14. So it can have different numbers of neutrons and still be the same chemical element. So the atomic number, the Z, is the number of protons. And if the atom is neutral, it has exactly the same number of electrons outside. And that determines the chemistry and how the atom interacts with other atoms. And then the atomic mass, the mass number is the sum. And again, an element is a single atomic number, but it can have different masses. It usually has a mixture of masses. And an isotope refers to any particular single mass number of one of these elements. So carbon isotope of mass 12 is what we call carbon 12, is 6 protons and 6 neutrons. So radioisotopes are, with different numbers of neutrons, they can either be stable or unstable. And so some isotopes are stable and lots of them are unstable. And on this curve, the black points are the stable isotopes. And again, here is carbon with 6 protons and 6 neutrons, and that's carbon 12, that's stable. The next one up would be carbon 13 on this chart. That's also stable, but then you get to carbon 14, it's not stable. It's radioactive. So a radioisotope is one that's radioactive, that's unstable, usually because it has too many or too few neutrons. And then what happens is it will decay, what we call a nuclear decay, any of a few different types, and either and it'll decay so it becomes closer to the stable zone. So we'll look at a couple different types of decays. One that's very common is what we call beta decay. That's where it emits an electron. And what happens is one of the neutrons, that if it has too many neutrons, one of the neutrons turns into a proton plus an electron. And the electron goes speeding out of the atom, and the proton turns it into a different element. So we'll see that with radiocarbon. And then it has a decay rate. It only depends on the nuclear structure, what the decay rate is of these radioactive isotopes, and is often expressed as the half-life, the time it takes for half of them to decay. So this is what the decay curve looks like. It's just if you start out with what we call a parent radioactive isotope, parent radioisotope, it decays and it produces a daughter isotope. So I don't know why it's a parent rather than a father or a mother, and I don't know why it's a daughter rather than a son, but that's the way it is. So the parent decays to a daughter at a constant rate, and just an exponential decay curve, since the rate is constant. As you get half of it gone, then there's less to decay, so it looks like it decays more slowly, but it's really going at a constant rate. And once half of it is gone, that's one half-life. And then you've got the daughter isotope that comes from it, and then you've got half of the maximum amount of that produced. So they just follow these exponential decay curves. Basic method of dating then is to measure the current amount of the parent or the daughter, depending whether you're trying to measure the parent or the daughter to do your dating. And then you need to know the original amount of the parent and possibly the daughter, if you're measuring based on the daughter. And then you just calculate the date based on the known decay rate. And usually you can get good answers to about 10 half-lives. So that's 10 half-lives is 2 to the 10th. You're down about a factor of 1,000 from the original concentration. So let's look at a couple of examples. Let's look at radiocarbon dating. The first radiocarbon date was done in 1948 by Willard Libby. He realized that carbon was unique and would allow dating of old things. 1950, he produced his first date list. In 1960, he won the Nobel Prize in Chemistry for the method. And they call out applications in archaeology, geology, geophysics, and other sciences. So 12 years after he first did it, he got the Nobel Prize, and it already had a number of applications. Carbon, we mentioned carbon has carbon-12, which is 6 protons and 6 neutrons. Carbon-13 is also stable. It has 1 extra neutron, and about 1% of naturally occurring carbon is carbon-13. And then carbon-14 is unstable. And about 1 part in 1 trillion of modern carbon is carbon-14. It has 2 extra neutrons over the carbon-12. And it decays to nitrogen-14 by beta decay. One of the neutrons in the carbon-14 turns into a proton, which turns into nitrogen-14 and an electron. And there's also a neutrino that is very hard to detect. So how does carbon-14 get made? It's what we call a cosmogenic isotope, which means it's generated by cosmic rays up in the upper atmosphere. So a cosmic ray will come at high energy and it'll break atoms apart, and it makes all kinds of fragments, including neutrons. And some of those neutrons can combine with nitrogen-14 to make carbon-14. So this is what we call an NP reaction. The neutron combines with the nitrogen and a proton goes flying out, and you end up with carbon-14. And so that's made in the upper atmosphere. And then the atmosphere itself kind of acts as a big reservoir, and it buffers any variations in production. So it's a big reservoir of carbon-14 in CO2 that's in the atmosphere. And so the CO2 in the atmosphere then gets taken in by plants through photosynthesis, and then that gets eaten by woolly mammoths, and those get eaten by people. And that's how the carbon-14 made up in the upper atmosphere gets into our bodies and into trees and in everything else. And then some gets dissolved into the ocean, and it can get into shells and other things as well. So half-life is about 5,700 years. And it decays then with beta decay, since it emits an electron, turns into nitrogen-14. And these individual decays, like all radioactive decays, are random, but the decay probability and the decay rate are constants. They depend only on the atomic nucleus. Half-life is about 5,730 years. And so this is important to get, that the rate of decay, the probability of decay, is a constant, and we don't know of anything that can change that other than changing the makeup of the nucleus itself. The nucleus is so small and so compact, anything external really can't have an effect on it. So temperatures, pressures, anything outside can't do much to change, to affect the decay rate of the atom. So the principle then of carbon-14 dating is living organisms are in equilibrium with the atmosphere. They're taking in radiocarbon as they live. And then you measure how much radiocarbon is in some sample, measure it as the fraction of modern carbon or percent of modern carbon, however you want to do it. And the decay equation, just this logarithmic decay curve that we looked at, exponential decay curve, gives the time that the organism died. So we can calculate back to how long ago the organism died. And radiocarbon age is usually expressed in BP, before present, where present is defined as 1950. You have to define some fixed point because it moves, but also because in the early 60s, nuclear bomb tests really messed up the amount of radiocarbon in the atmosphere. So you got to go back before that. So the original dating method by Libby was to measure how much carbon-14 is in your unknown sample, and they counted by counting these electrons that came off in a big lead-lined counter. You assume the decay rate of 5568 years. That's not exactly the decay rate, but that's the one he used. And you assume original carbon-14 concentration is the same as the present value, that the atmosphere always has the same constant amount of carbon-14 in it. And then you can calculate the age of the sample. And that method works pretty well. There are a few assumptions here. His decay rate is a bit wrong. And the main assumption is that the concentration in the atmosphere through all time in the past is the same as it is now. And that's not exactly right, but it's pretty constant. It just fluctuates a bit. There's wiggles. But this method of Libby has been improved tremendously by what we call calibration of radiocarbon. And this made such a big effect, it was called a second radiocarbon revolution by Irv Taylor, one of the guys who mentored me years ago. And what we do is we look at tree rings or lake varves, and we can use them to give a calibration, to give a correction for radiocarbon. It corrects for this initial amount that was in the atmosphere. So how does this work? So you look at the tree rings. Trees have thick and thin rings that are annual. and I forget which one's the dense one and which one's the big one. I guess when it grows fast, it's the less dense, and when it doesn't, it's the more dense. But you get annual rings, and some trees are better at that than others. Some of the oaks and bristlecone pines are very reliable in giving annual rings. Some other ones you can miss the rings when you try to count them. The oldest living tree is about 4,600 years old, but you can extend the record back by looking at fossilized trees, by looking at trees in old buildings, trees that you found buried in the ground, matching up the tree rings, and you can go back to about 14,000 years that way. And cross comparisons show excellent agreement. This is an idea, this is a picture from our friend Ken Wolgamuth that shows how you work backwards on these tree rings. So here's a living tree, and you've got a tree ring record with narrow and wide bands going to the center of this living tree. And then you find a tree that's in some old archaeological structure, and you can match up the bands there. And then you measure how much radiocarbon is in each of these. And the ones that overlap will have the same amount of radiocarbon. And then you can extend the record back further. And then you can find trees that were buried and nearly fossilized, and you can extend the record back further yet. So by doing this, we've extended the record back about 14,000 years. And that means we can find an unknown sample and essentially compare it to this tree ring record going back 14,000 years and get a good date. This shows measurements by 4 different labs, and you see they lie all on top of each other. The 4 labs measurements are quite consistent. The 4 symbols here are all pretty much on top. This one's out a bit in a few places. Belfast, something was wrong with those measurements, but there's quite good consistency. And the correction that you're making, if you did it through Libby's method without correcting with tree ring calibrations, you'd be off by about 15% 5,000 years ago. That's about your maximum error. And as you go back further, you get a bit less error than that. So there's some error, but it's not huge by using the old method. The new method, though, the calibrated dates, takes away a lot of the assumptions that people complain about radioisotope dating. And we can extend it even beyond the 14,000 years by lake varves. There's some lakes that have annual layers, just like trees. This one in Japan, Lake Tsujetsu, has annual layers because of the flora around the lake. Well, the diatoms, I guess. Springtime diatoms make these layers in the lake. It's not flora, is it? And then there's one in Scandinavia that is used that they can see annual layers because of the silt that comes in from glacial melt. So going back with these, you count the layers, and then you find little organic inclusions, little pieces of twig or something that fell into the lake. You carbon date that, and then you have a carbon date going back many more years than you can get with actual tree rings. And so from that, we've been able to extend the carbon radiocarbon calibration to about 45,000 years. So this is a bit of an older plot. This is the calibration curve, I think, from 2019, maybe even earlier. There's the most recent one that's been done is 2020. And but I didn't have a full plot of that to show you. So calibration is very powerful, like I said. Essentially what you're doing is taking an unknown, measuring how much radiocarbon, comparing that to the radiocarbon in things where you've counted the annual layers, whether they're trees or lake varves. So it does not depend on a constant decay rate or constant original concentration. So what if the decay rate had changed 5,000 years ago and radiocarbon used to decay a lot faster and then it slowed down? Well, that would be reflected in the tree rings and the lake varves just as well as in the unknown sample. So they'd all track. And by counting the rings, you would know how old it was. Even if the decay rate had changed, it wouldn't affect the calibrated date. Or if the original concentration was something different than you expected, that all cancels out as well, because you're looking at what went into the tree rings that you've counted and into your unknown sample and just comparing them. The only thing that it depends on is your ability to count these rings. The rings are the lake varves. So almost all of the assumptions that people raise to complain about radiocarbon dating, they don't apply to calibrated dates. And this is something that I think the young Earth creation community has not quite understood. They keep complaining about all these assumptions, which are not made anymore. That was the old method, not the new method. Now, there's another development beyond that, which Irv Taylor called a third radiocarbon revolution, and that's to use accelerator mass spectrometer. Use a particle accelerator to count the atoms of carbon-14 rather than using a big lead-lined counter to count the decays of carbon-14. When you're counting decays, if you have a small sample, it's going to take a long time to measure something. And so you have a limit as to how small of a sample you can use. Accelerator mass spectrometry, you can use very small samples, and you're counting the atoms of carbon-14 rather than decays. So it's about 1,000 times less material that you need in your sample. You can get a good measurement with a milligram of carbon rather than a gram of carbon. And it's about 1,000 times faster, a few minutes instead of a few days. So why do you need a particle accelerator to do this? Why not just a magnetic mass spectrometer like is used for a lot of other things? It's because the radiocarbon has such a low abundance compared to the carbon-12. Carbon-12 is up here, abundance of 1. We're normalizing to carbon-12. And if you run a sample through a mass spectrometer, you get some carbon-13 and some CH radicals, molecular ions. And then at mass 14, what you're going to see is these CH molecular ions coming out of your machine. You won't see the carbon-14. It's such a small abundance. So you need some sort of a technique that gets rid of these molecular ions, and some nuclear physics techniques are used to do that. And what they do is you take your sample, put it in this ion source, you make ions of carbon coming out, you put them into an accelerator. This is a tandem accelerator. Accelerate those up to 6 million volts, go through a stripping foil, accelerate them down to another 18.5 or 19 million volts. And you're going in at a -1 and you're coming out at a +3. So you get 4 times 6.5. So you get about 25 million volts energy coming out of the thing. And then your radiocarbon comes around here, you do some cleanup filtering of it, and then you put it into a nuclear physics style ionization detector. And that's how most radiocarbon dates are done these days. Some people still use the counters, but the accelerator mass spectrometry is so much faster, and you could use so much smaller samples. This is here's pictures of a couple labs. This is the lab in Livermore. I worked there, but I'm not in this picture. This was taken after I left. So that's the accelerator at the Livermore lab. And here's the isotrace lab in Toronto, uses a smaller accelerator. That's the one at Livermore was a big general purpose nuclear physics accelerator. The one at isotrace is a small one designed just for radiocarbon. And the result is, with modern radiocarbon, we can do about 1 milligram of carbon as a sample size. And we can get, well, it's 14,000 years now for tree rings, about 45,000 for lake varves. You can get back to about 60,000 years uncalibrated age without doing any heroic stuff, and about 75,000 if you do all kinds of fancy things. And you can get about a 1% or less than 1% measurement error, which equates to about a plus or minus 30 years on a date. So that's what you can do now with radiocarbon. And there's quite a few details. I'm not going to go into these unless you want to ask in the Q&A period at the end. But there's tricks on preparing the sample. There's subtleties about contamination and background in the instruments. There's some interesting corrections you need to make for mass fractionation. Marine dates, if you're trying to date things that are in the ocean, like shells, ocean water tends to be older. The CO2 that's dissolved in the ocean tends to be older. It can be up to like 1,700 years older than the atmosphere. So if you don't know that and you date it, you'll think this living clam is 1,700 years old when he's not. And then there's issues with various materials that are difficult to date. But let's look at some applications. There's quite a few: archaeology, geoscience, climatology, bioscience. And I want to look at a couple of specific, well, 3 specific examples: the ICR Rate Project and the Dead Sea Scrolls and the Shroud of Turin. Now, the Rate Project was an attempt by the Institute for Creation Research to reinterpret radioisotope dating. Radioisotope dating it's pretty straightforward, and it shows that things are very old, and so that conflicts with young Earth creation perspective. So they've got to figure out some way to reinterpret these radioisotope ages and make them younger. And their claim, after they did a big study, their claim was that radiocarbon background and contamination, that the labs called background and contamination, their claim is these are really intrinsic radiocarbon left over from creation. And so the universe is not as old as we think it is. The radiocarbon that's there is all just left over from creation. And they looked at a whole bunch of different things. And my response, you can read it in detail. It's at these 2 sites. It used to be on the RTB site as well, but they redid things and moved things around, and I can't find it anymore. I'll have to ask them to put it back up. But Rodney is the one who prodded me to look into this. And after he prodded me a few times, I finally reluctantly went and looked into their study. And I think I figured out what they misinterpreted, and I wrote up a response to it. So there are specific problems in this study. They made wrong assumptions about background levels, and their own references in their study where they claim to see intrinsic radiocarbon, those references show that this is really background of the instruments and of the process. And they confused a bunch of samples. They confused ones that were processed chemically and ones that were unprocessed. And they made bad assumptions about the instrument background. So I think they're just seeing instrument background and chemical process background, and they're thinking that's intrinsic. Dead Sea Scrolls. The Dead Sea Scrolls have been carbon dated. Oops, sorry. And I had thought about this back when I was working at Livermore. I was looking for interesting things to date. I thought about doing this. I talked to an Old Testament scholar, and he discouraged me because he said they know pretty well what the dates are through the paleographic studies. You study the handwriting analysis, and you can tell pretty accurately how old things are. And you see on this chart, the red hashes and the red lines are the paleographic dates. So those are the dates of each of these individual scrolls. So there's a bunch of different scrolls in the Dead Sea Scrolls over a few hundred years. They were placed there. And the paleographic dates are pretty narrow in some cases, and in other cases they're pretty wide. And the blue bars are the 1 sigma error bars on the radiocarbon dates. On average, the radiocarbon is a bit older than the paleographic dates. And that could be real. It could mean that some of the materials had been, maybe 35 years old before they were written on. I'm not sure, but it may be real, and some may have been contaminated with glue. These down here at the oldest ones, there was at least one of the Dead Sea Scrolls that they did know had been repaired with some glue. And that's some kind of a hydrocarbon based thing. It'll throw off the date. So this is another slide courtesy of Ken Wolgamuth. The Isaiah scroll there's a complete book of Isaiah in the Dead Sea Scrolls, and that dates from about 100 BC. And if you look at the radiocarbon dates on that, it's clear that it was written before Christ, and the copy that's in the cave one at Qumran is written before Christ. And you've got these remarkable predictions of Jesus there in Isaiah 53. Ken's also got an interesting thing here about Hezekiah's tunnel. And that's a tunnel that was made by King Hezekiah in, what is it? First Kings, Second Kings, it talks about how he built this tunnel. And the tunnel has been dated, and it comes out to be right about when it should be, right around Hezekiah's reign. And the Shroud of Turin. The Shroud of Turin is it's a controversial item, but this is the first date that was done by, what do they call an interlab comparison. 3 different labs got samples from the shroud, and they all independently dated those samples, and they consistently came up with a medieval date. So Arizona, these are the 4 numbers they got on 4 different subsamples that they broke it into, and Oxford and Zurich. So their conclusion was that the material that they dated from the shroud was clearly medieval. It was not 1st century. It was like 1400 AD or 1300 AD, something like that. And here's their quote: "Very small samples from the shroud have been dated by accelerator mass spectrometry in these 3 labs." And as controls, 3 samples whose age had been independently determined were also dated. These results provide conclusive evidence that the Shroud of Turin is medieval. Well, people have complained since then and tried to figure out, people who believe the shroud is first century have tried to figure out how this could have been. And all kinds of interesting creative theories have been put forth. I think the only possibility, I think it's clear that the piece of linens that were dated are medieval. So the only possibility is that what they dated was completely a patch that was not detected by the people taking the samples, who were trying to be careful not to take a patch. So I think the evidence leans very strongly to the shroud being medieval. And so then one other technique I want to look at is potassium-argon dating. Potassium-argon dating is good for dating igneous rock. We look at potassium-40, and it decays 2 different ways. Some of it decays to argon-40 by electron capture. And so how do we date with potassium-argon? With radiocarbon, we're looking at the parent and measuring the parent, this carbon-14, as it drops down. With potassium-argon, we're looking at the daughter. So we're measuring this daughter isotope, the argon-40. And the reason this works is with igneous rock, it's molten. Argon is what we call a noble gas. It doesn't combine with anything chemically. And it's a gas at normal room temperature, and when it's hot, it's a gas. So when the lava comes out, any argon that's there just bubbles out, it leaves. So when the argon when the lava solidifies, it starts with 0 argon. So you know how much argon is there initially. So what you do is you measure the argon at some point in the future, and then you can calculate how much is left. Well, you can calculate how old things are if you know how much potassium is there, but you can measure the amount of potassium, and the half-life is so long, you can correct for the amount of potassium that was there initially. So half-life is 1.2 billion years for potassium argon. And so you can get good dates on lava and on igneous rock. Now you're assuming that there's no initial argon in the sample, and no argon leaked out of the sample or into the sample. These assumptions are usually good, but they're not always good. For example, if the lava comes out underwater or under high pressure and cools very quickly, it can freeze in some argon. And also argon can leak in or out of the sample. But there's a newer method called argon-39, argon-40, or argon-argon method, that corrects for these things as well. So it's very good for dating igneous rock. Here's an example, courtesy of Greg Davidson. The Hawaiian Islands are right here. They're part of a big chain of islands that connects up to the Emperor's Seamounts and goes toward Japan. And what's happening is the crust, this crustal plate, is moving across a hot spot that's right now under the Big Island in Hawaii. And the other Hawaiian islands have moved off of that hot spot. And we can use potassium argon or argon-argon, and we can date the lava flows in this chain. And these are the dates in millions of years. On Hawaii here, it's the current spot is where we get flows now is 0. And then 2 million years up at the tip. And then going along the chain all the way up to 80 million years with potassium argon or argon argon. And again, the decay rates are constant. Nothing changes the decay rate. We could be wrong about the initial concentrations of argon with the old method, the potassium argon, but this newer argon-argon method corrects for any initial amount of argon that was in the rock. So this is a pretty good technique, pretty reliable, and we can get very accurate dates using argon-argon. So summary, radiocarbon has been calibrated about 45,000 years, and these calibrated dates do not depend on what the young Earth creationists like to call uniformitarian assumptions. And the newer AMS allows very small samples to be carbon dated. Potassium argon is very good for igneous rock, and the argon-argon method corrects for anomalies that we might have. So the conclusion, I think, is the universe is very old, and God has given us some techniques here that we can use to study the universe and to learn about it, learn about some of these things like the movement of the plates over hotspots on the Earth. We can learn about things in the past civilizations with radiocarbon, and just lots of things that we can find out from radioisotope dating. There's a few references, but there's probably a lot more we could have. So, all right, I guess we're open for questions.
The hotspots, how are we certain that those haven't changed over time?
Well, there's that one hotspot, and the plate is moving over it, so far as we know. We can, I guess I'm not quite following the question.
Oh, well, I mean, we're looking at what, 80 million years to,
Yeah.
We're assuming that hotspot has been constant for 80 million years. Is that right?
Yeah. Well, it's a good question, and all I can say is everything is consistent.
Well, and it does seem like the plates are clearly moving, right? I mean, so the assumption is that the hotspot is a constant in a constant location, and that would make some sense.
Yeah, because it's coming from a deeper depth in the Earth, and so
Right.
for the hotspot to move, it would have to find a new pathway to the surface, which doesn't seem very likely.
Yeah, let's see. I think I have a couple other slides here that
But
where'd my screen go?
might not the characteristics of the crust on, that surrounds the top of the hotspot be a variable there? I mean,
Yeah, I can't find my other slides right now, but I've got some slides where they look at the motion of the plate with you can measure it with satellites. They've measured how fast the plate is moving, something like 3 inches per year, I believe. And you can look historically at these dates and put them on a line and plot them, and it matches up to average about 3 inches per year. So the apparent motion due to the volcanoes and the current motion measured by satellite agree. But that doesn't prove that the hotspot hasn't moved.
yeah.
Yeah, I don't know. That's a question for a geologist. I'm just a lowly physicist.
Well,
That
I'm
wouldn't
not a
have much to do
geologist
with-
either, Kirk, but I can't see what the effect would be of the hotspot moving versus the plate moving.
But I would probably make things a little bit more difficult to tell what the dates are, though.
Yeah.
Would it?
I mean, it would change the it would
It probably mess up the dates. Yeah.
yeah. But
I'm
still,
not,
I mean,
quite sure understand why or how.
if the question is the Earth more than 6,000 to 10,000 years old?
Yeah.
We're talking millions of years for those hotspots, or for the islands to have formed. So
Yeah, I guess we could say that the hotspot hasn't moved recently, because the recent measurements, current measurements from satellite of the motion of the plate match with, the recent motion of the plate there. So it's as if the hotspot is stationary and the plate is moving. So I think to get any more, you'd need a real geologist.
Well, it makes sense, whoever brought that up with the consistency of the amount of time that we're interested in. So it might be a moot point.
Yeah.
Can I ask a question?
go ahead, Ari.
So if I understand you right, Kirk, you think that carbon-14 data is fairly accurate when combined with tree ring and lake varve data is pretty accurate to a certain point, like 15 half-lives, I believe you said. How many thousands of years is that? And why is it that if it's accurate, why do young Earth creationists say it's not?
So it's good back to about 45,000 years, which is where our Lake Varve records go back to. And I would trust it, with increasing error bars, I would trust it to about 60,000. When you get beyond that, it gets really hard to make measurements.
Okay, so when you combine that with actually counting the tree ring data, one layer per year, and the varve data and everything corresponding and matching up, the carbon-14 in a twig that's trapped in the lake varves and so forth. Isn't that irrefutable evidence that the Earth is at least whatever that is, 45,000 years to the oldest lake varve? I mean, it seems like the only way around that would be to claim that there's multiple layers being laid down per year, but the tree rings, that's just doesn't seem plausible because of so many different dating methods when you look at tree rings and everything else.
Yeah, I agree with you. I think it's pretty clear that it's a good method.
Have you found any of the young Earth creationist arguments at all plausible, or are they just totally off the wall and just lacking credibility?
Well, I don't find their arguments plausible, and so the problem is they've made their conclusion, and then they look at the data and try to force the data to fit.
Right.
So they come at it with a preconceived conclusion about how things work. And they had I had a picture of Isotrace Lab in Toronto on one of my slides. The Institute for Creation Research hired a guy who had come from that lab who understood radiocarbon, but they fired him eventually. So they did have one of their guys in their camp who really understood this stuff, who had worked with it. Gerald Ardsma is his name. But they did not include him in their rate study. He wasn't consulted for it. So he's still a young Earth creationist, but he doesn't quite agree with ICR on a number of things. So I guess they had a falling out and they didn't want to call him in. But the guys that were working on the rate study, I'm convinced, did not understand contamination and background and a lot of the things on that are done with the AMS. And that other people who try to complain about the dendrochronology in the lake varves. The tree ring laboratory, the National Tree Ring Laboratory, is at University of Arizona, and quite a few young Earth creationists came through there. They opened their doors and let people, look and see what they were doing. Quite a few went in to try to find flaws with the way they were doing with their the tree ring records. And so far as I know, nobody has raised any flaws to how that's done. So I don't know what they say to the varves. They probably say, like you implied, that people are just counting wrong, but the tree rings themselves go back 14,000 years. So that's already double the age of the Earth, according to the young Earth creationists.
Well, I understand some young Earth creationists say 6 to 10,000 years. So
Yeah.
But yeah, it's 14,000 is clearly more than 10.
Yeah.
Right. And then ice cores go back hundreds of thousands of years.
Yeah.
And then you'd have to claim that multiple layers are being laid down per year. But then I think those also are correlated to tree ring and rock deposits or whatever data, right?
Yeah, I don't think they're using ice cores for any of these calibrations. Probably, well, I'm not sure why. They do use speleothems, and it took them quite a while to figure out, stalactites and stalagmites. It took them quite a while to figure out how they could correlate those with the other stuff in the calibration, radiocarbon calibration curves, but they've figured out how to do that.
Yeah, it seems like they could, I mean, because they've used ice cores to measure the CO2 content and
Yeah.
in the atmosphere over millions or whatever, hundreds of thousands of years. So it seems like they could measure the ratio of C14 versus C12 or whatever, the daughter
Yeah.
and the parent that way.
There's probably not enough. What they do to measure the CO2 is they're actually looking at the gas that's trapped in the ice.
Right.
There's probably not enough radiocarbon in the gas there to
Okay.
make a measurement.
Right. One other question about the Dead Sea Scrolls. What is the dating method they used for Isaiah to put it at 100 BC? Is it actually the something about the chemistry of the scroll material, or is it the shape of the letters and to date it for the writing period of that?
It's both, actually.
Okay.
The paleographic date was done by the shape of the letters, but the radiocarbon date was done on the material itself.
Okay. That's what that graph shows is the
Yeah,
two overlaid with each
and
other.
they agree. Yeah.
Okay, thank you.
So Doug has his hand up. Maybe Doug can ask the
Doug,
question next.
you have to unmute, Doug.
Great question. Great presentation, and I got a few questions.
Oh,
I
good.
was hoping I could make a comment too, if I may. One of them is that in my conversations with people who are kind of committed young earthers, one thing that often comes up, and I'm curious to know what your recommendation is regarding a strategy to answer this. But one common objection people I've run into is some guy comes up with this claim that okay, we took our kid's leather shoe and in the closet cut off a chunk and sent it in for dating, and we got 25 million years for the, there's these claims by quite a few actually young earthers of claims to have sent in samples with wild dates that have come back. I think I know how to answer that, but I'm curious to know how you would handle that.
Well, you probably have to do it individually for each one and ask them, what it was. So people at radiocarbon dating labs like to know as much as possible about the sample before they run the date. And people who don't work in radiocarbon dating labs they tend to think, well, you should just be able to take some unknown sample and tell me how old it is without knowing anything about it. The trouble is, in order to prepare the sample and do the proper chemistry on it, the more you know about it, the better. And if you don't know a lot about it, what you try to do then is you try to break up the sample into pieces if you're being really careful. So, for example, the shroud samples that were sent in, the 3 labs each split their samples, and on one piece, and we did the same stuff at Livermore when we wanted to be really careful in a study. On one piece, they did a very mild chemical processing. So they did kind of the mildest thing possible to clean the sample off. On the other piece, they did a very harsh chemical processing that would get off any kind of contamination that was there. Problem is, when you use these harsh methods, you're adding a little bit of carbon because all the chemicals you're using have a bit of trace carbon in them. And so you mess up the date slightly. But you do it both ways because you don't know how contaminated the sample is. So if a sample is sent off and the lab doesn't know anything about it, they may not get out all the contamination that was there. Or they may use improper methods. And often these samples that you're talking about are sent in, and the lab comes back and says it's background level. It's really, really low. It's background level. And then the people who sent the sample in will interpret that as, there is radiocarbon there. And it's, 30,000, 50,000 years old, whatever. Where what the lab is trying to say is it's more than 50,000 years old. It could be millions of years old. So there's misinterpretations like that when people, they don't believe the background really is the background, and they want to say it's the actual amount of radiocarbon in the sample. So I don't know if that answers your question, but you'd have to see the individual samples.
I think if somebody said something like that to me, I'd say, "Oh, that is really interesting. I would love to get a copy of the data of the lab's report."
Yeah.
And to compare it with what I know about that lab, which is quite a lot, if I'm Kirk Bertsche. And well, of course, you and I aren't Kirk Bertsche, Doug, but ask them about the lab and ask them about the sample itself, and wouldn't they have seen that this was just a tongue of a shoe and figured that that's probably not very old anyway? So what kind of a lab is this that would give you a date estimate like so ridiculous?
And also ask them what they told the lab. One of the things, some of the young Earth creationists have been sending things to labs to be dated, and they'll send a dinosaur bone. Well, the lab doesn't want to hear that this is a dinosaur bone because it won't have any radiocarbon in it. So what do the young Earth creationists do? They say, well, this is a dog bone or something like that. They'll lie about what the sample is, and then the lab will think this is a recent bone, and they won't do the proper sample prep, and they'll get a wrong date. So that happens too.
So what I'm hearing then is that there are protocols for these things.
Yeah.
And if you don't follow the protocols, it's not a big surprise that you're going to get a false answer.
Yeah.
Which is kind of the way I think what I'm hearing your answer is, which is kind of what I would want to say. I was hoping to make a brief comment. I guess John
Sure.
Ray has a question there. I don't want to hold him up, but just a quick comment though. I mean,
No, go
I've
ahead.
had to do what?
I said, go ahead.
Oh,
Yeah.
sorry. Okay.
No problem. No problem.
Thank you, John. I just wanted to say there's a logic to what you're saying that I just want to make sure we're thinking the same way. I'm pretty sure we are. I worked in physics too, doing research. That was my degree was in physics. And one of the things that let me just tell you a story. Years ago, in fact, when I was living in Fremont, California, we had to get our windows done. And I know nothing about buying windows, nothing. So what we did was we went out and got like 5, 6 estimates. We had 5 or 6 contractors come in and tell us their story, tell us how much they wanted to do it. These guys did not know each other. They were independent. And then they would tell us how much it would cost, what they thought they needed to do, and we'd listen to 5 or 6 stories, as many as we could. When you do that, I mean, the problem is if you're lying, usually there's a huge scatter in the answers you're going to get back. And usually if one individual is lying, it'll be an outlier in that situation. I frankly think that physics research works the same way. If you have independent diagnostics for particular measurement, in my case, it was plasma physics for plasma processing. I had 2 or 3 diagnostics and I was getting the same answer and they were independent measurements. I had good reason to think that even if I wasn't sure about one individual or even all 3 or 4 individual measurements by themselves, I still had warrant for believing the result. Is that logic making sense?
Yeah.
If they're independent. So if you're talking about lake varves, if you're talking about, I was surprised that you only cited lake varves and tree rings. I thought there was a lot more, and later on you seem to hint that there are a lot more. But the
Relay
more
lines.
of these that you have, and they're independent, they're not talking to each other, the more warrant I think you've got for concluding that you have an honest answer. So
Yeah.
you can maybe comment on whether you think I'm crazy or not.
Yeah, well, and also the trees there's at least 4 different, I showed a plot that had 4 different species of trees in different continents, and they matched up. So you get good consistency on different trees, different labs, different measurements.
And they're not talking to each other. They're all independent. These guys didn't know each other existed, right?
Well,
Pretty
they
much.
know each other exist, but the measurements were done independently, so far as I know.
Okay. Well,
And that
I
was
have other
certainly
questions that
the
I'll wait
case for the shroud. There were 3 independent labs. So, yep.
So I think John is you had a question, John?
Ray.
Yeah, my comment, can you hear me?
Yes.
Okay, good. You were talking about the shroud, and I've seen some recent things where the sample side was related to where they had done a repair, and it could have been repaired in the Middle Ages and the material that would have been used. And so then there's another method that gives they used X-rays or something to scatter, and they could got an older age of 2,000 years. So, and then I had a question that it seemed like the people that were talking to Doug regarding the criticism, if you mentioned that they were saying that they're getting millions of years, that's impossible with carbon-14. So I would ask more questions about what criticism of the method that was used, and as I think, I can't remember if it was Kirby or not, but yeah, you want evidence of what they're talking about, because and when I've engaged with Young Earth, they repeat a lot of things, but they don't know what they're really saying. So, because they're not really scientific in their understanding of things, they're not trained scientifically.
Yeah, Doug, if you actually meant millions of years, yeah, they're if they say that, then it's obviously not. They're confused. That's not radiocarbon. Radiocarbon is going to give you something like.
I'm
Yeah.
forgetting the numbers actually. So it was some outrageous number though.
Yeah.
Probably thousands.
Yeah. So 45,000 is kind of background level. 30 to 60,000 is typical lab background. So if they say somewhere like 30 to 60,000, then that means it's just basically really old. And John, on your comments on the shroud, yeah, I've seen some claims recently that people think, or they want to think at least, that this was a repair. I think in order to get the date that they got, the material would have to be something like 85% repair material and 15% original. I guess it depends on when it was repaired. So if it was repaired at the right time, it could have been just 100% repair material. But it's got to be mostly repair material because the date was medieval, and they were very careful when they picked a a place to sample the shroud, they were very careful to get a place that they did not think was repaired. They could have been wrong.
Yeah, that's cool.
Yeah, but this was, the folks who have the shroud and allowed it to be sampled. So they were trying to be careful. The other recent date that you mentioned, I forget the technique, but it was a thermochemical technique that they were using. And thermochemical techniques are very good if you know the entire thermal history of the item you're trying to date. But thermochemical techniques, what's the rule of thumb? If you go up 10 degrees C, you double a reaction rate. I think that's the way it goes. Mm-hmm. So these thermochemical things, if the sample that you're dating had gone up to a high temperature at some point in the past, it's going to look a lot older from these techniques than it really is. And we know the shroud was involved in a couple of fires. So I think that thermochemical technique that they were using is just not the right technique for the shroud.
Just to dovetail onto that, on the slide where you showed those numbers, you had another column that showed older dates. What was that column? I thought it said AMS at the top.
Yeah, that was the 3 labs they dated. So they were not given just the shroud. They were given the shroud plus 2 or 3 other materials, and they were supposed to do all of these. One of the materials was an ancient Egyptian thing that was from like 2000 BC or something. And I think that's the one that was on the chart.
Okay.
So it was showing that they all got consistent dates for that one as well.
Okay, thank you. And now Carl has a question.
Yeah, I think Carl was next.
Yes, I was wondering if if a young Earth creationist saw the recording of this session, what do you think they'd respond? Any idea?
Oh yeah, when I posted my thing about the rate response, they responded, and they had me up on their, I think it was Answers in Genesis, had me up as the heretic of the day, and I was a compromiser because I have compromised with this old Earth creation folks.
So they're using an ad hominem argument rather than a scientific one, basically.
Yeah.
John, I guess you're next.
Hey there. I was wondering, how much does it cost to get like a sample date dated if you were just to send something out?
So there's a few labs that do this. I don't know what the charge is these days, but if you want them to do a really careful job, you have to pay more because they're going to have to split your sample into pieces. One lab that does it is Beta Analytic, and I think they're in Florida. Another lab that may still do it is Isotrace Lab there in Toronto. They
But ballpark, are we talking like 5,000-10,000 for a go around versus something like 50 to 100 grand or something? Or
for a basic date, I'll probably, I bet it's less than 1,000.
Okay, you were going to say you would do it for 500, right?
I'm probably a few $100. But yeah, if you're associated with a lab, which I'm not anymore, but I could.
You get a discount.
But we know, but Kirk, we know you're a cheapskate, so I think we have to take your number and multiply it by at least 10.
Maybe I don't know. You could. I haven't looked. Somebody could look online at Beta Analytic and see what they charge.
I had a follow-on question. So it seems like the 2 major forms that you presented today were kind of like radiocarbon 14 in the tens of thousands of years, and then we have millions and billions of years with I guess the potassium argon or argon. Is there something like in the middle that we can use for hundreds of thousands of years reliably? So I'm thinking about stuff like maybe like 200,000 to, I don't know, maybe about 1 million. So if we start to explore maybe like early hominims different things that maybe a technique that might date that particular eon better?
Yeah, I'm not sure. I didn't go into the other ones. Another common one is rubidium strontium that is used. Let me see what that half-life is. Come on, tell me the half-life here.
I think while you're looking that up, I can't resist but comment that this is a question that Fuzz Rana has been looking at, because that zone that's beyond 50,000 years to around 200,000 years, according to him, there's something called luminescence dating that's very, very unreliable.
Yeah, that's
And,
another thermochemical
it's-
technique. Yeah,
Pardon?
that's another thermochemical technique. It depends on knowing, history, detailed history of the temperature of the stuff. And so if you don't know that, it can be very unreliable. Yeah.
And so that raises a lot of questions for for these remains that they're dating that they're saying are modern Homo sapiens or not so modern Homo sapiens. The question, there's a pretty big error bar, I think, on those dates that they come up with.
Yeah.
And they tend not to talk about the error bar, which is another thing that Hugh Ross mentions quite often, is it doesn't do much good if you talk about a specific date without telling what the error bars are.
I think the argon and potassium argon are good for a few million years, but if you're talking 100,000 years, I'm not sure what's in that range.
Mm-hmm.
It could be there's these other techniques, rubidium strontium and lead methods and other stuff.
Right, and depending on what we're actually trying to date, we have that additional complexity as well, right? Because if it's stuff we're talking about like early again, homonyms, right? We probably want something that can measure carbon, right? And so I'm not sure how rubidium strontium would
carbon's going to be tough, but if you could find something that'll work with calcium, that would work for the bones. And so the chemicals have to be the right thing too. So potassium argon is really nice for igneous rock because it tends to have a lot of potassium in it, and when it's molten, it's got no argon. So it's a good technique for measuring time since it hardened. And carbon is good for human things because they're all carbon based.
So I see David Wu has his hand up.
Yes, Kirby, I have a question. We talk about carbon 14 dating in a long range, backgrounds roughly between 30 to 60,000 years. What is the closest years still the range still maintain its reliability and sensitive range? Can it date something within 10 years, within 100 years, 50 years, or 5 years? What is that? At what point it loses its sensitivity?
Well, it kind of depends on the there we go. It depends on where you are on this calibration line. There's places here where the calibration curve is steep, and then you get a very precise date. There's places where it's very shallow, like in here. You're not going to be able to tell which of these dates it is. You get a radiocarbon content that would equate to 4,200 years old, uncalibrated, and you go over here to calibrate it. It could be anywhere from what is that, 2600 BC to 2900 BC. So you got like a 300-year range that whole 300 years has almost the same amount of radiocarbon. So you
Oh,
can't
I
tell.
see. So what method do we use if we want to date something shorter than that? Let's say forensic dating. Someone was murdered and want to find out this person died 100 years ago, 50 years ago, 20 years ago. What method do we use?
Yeah, well, if you want to measure something very recent, you're in luck, because here is 1960. So 1950 is what we call present in radiocarbon dating. In the early 1960s, atmospheric nuclear bomb tests raised the amount of radiocarbon in the atmosphere tremendously. It almost doubled it. So it went up 90% above where it was. So it almost doubled the radiocarbon in the atmosphere. And then everybody stopped doing atmospheric tests. I think there was an international treaty. And since then, the radiocarbon in the atmosphere has been dropping very fast. So something from dating after about 1965, you could get a 1 or 2 year date out of radiocarbon. And in fact, I was at a conference where the Austrian Wine Board was proposing to verify the dates of the wine by doing radiocarbon dating on each one, on each batch, because they could get a 1 year accuracy and they could make sure the guys were putting the right vintage on the bottle.
Thank you.
Sabina, I think you're next.
Okay, so David asked about the recent times, and I actually have a question about the older times. So, Kirk, when you were showing us how the tree rings and the lake barbs
Lake barbs.
yeah, where overlapping and showing this is correct and this is correct. I'm just wondering, and then we have igneous rock at that end. We have the present, and here we have the far past. Is there some place where those start overlapping, where we know that something goes back to, I don't know, 60,000 years ago, based on the trees and the radiometric testing, and then we can confirm that? I mean, are there rocks? No, I guess there wouldn't be rocks that would be 70,000 years old. They would all be way older.
No.
So, well, no, there would be.
Well,
volcanoes.
There's volcanoes that have erupted within the.
Yeah, even right now.
Sure.
Okay, so I guess I'm just wondering, is there some place where those two or those things start overlapping?
Yeah, the problem is with the volcanic stuff, since the half-life is 1.2 billion years, or something like that, then when you're talking 60,000 years, it's just that's too tight of resolution. You can't get that good a resolution. So you can get kind of a million-year resolution out of potassium argon, but to get much better than that, it's going to be tough.
So basically, just a follow-up for me to clarify, and of course I can ask you later, but so they have to do with two separate areas of measurement, the rocks and the potassium, the argon, and the radiometric or radioisotope.
Yeah, so if you look at a recent lava flow in Hawaii and measure it with argon, you're going to find that it's got basically no argon in it. Might be a very small trace amount, but your error bars are going to be something like 1 million years. So you just can't get the resolution that tight.
Randy?
Yeah, and Kirk, thank you. I learned a lot from your presentation. I guess we've been down to where the rubber meets the road with the dating, and I appreciate that. What I'm interested in goes back to reasons to believe. I've given by this. I mean, I correct me if I'm wrong, but sounds like we're pretty good about dating. For a pretty broad range of pretty broad time frame. So I mean, that's good news. And I've been given, I have reasons to disbelieve the young Earth creationists at this point. Based on discussions and what the things that people have brought up. What would the group say to an agnostic or an atheist? What is it? Is there anything we can say about dating as it pertains to dating on reasons to believe the God of the Bible?
Well, first thing I'd say is it's consistent with things being old. The verse I put up, let me put this up again. So the verse at the bottom there, before the mountains were born, or you brought forth the whole world, from everlasting to everlasting, you are God. 1,000 years in your sight are like a day that's just gone by, or like a watch in the night. And this is a psalm of Moses, not David. And Moses is just, commenting on the universe, the creation. And the implication I get from this is that he thinks things are pretty old. Now, in his mind, pretty old might have been 1,000 years, not billions, but he's kind of thinking about how old the universe is and how God brought it forth long ago. So what we're seeing here is consistent with that. That doesn't prove that it's true, but it's consistent.
Well, but if he's talking thousands of years, I mean, you made a statement there, he's talking thousands of years instead of, hundreds of thousands, or whatever term you use.
That's probably what he was thinking, but I can't be sure.
Isn't that problematic?
Well, he wouldn't have had any idea about, exactly how old, unless God had told him. And
Right.
it doesn't sound like God did tell him, because it doesn't tell us that in the Bible. But
Do we have like, I guess what I'm looking for is, do we have the archaeological evidence that has been dated back to, that corresponds to the Bible, that corresponds to events? This is the kind of thing that would give a lot more credibility in the minds of non-believers.
Well, I showed you the Dead Sea Scrolls, which, one of those has the whole book of Isaiah, including Isaiah 53, which has prophecies of Jesus.
But what I got from that is that just was in the time before Jesus, right?
Yeah.
I mean, that's a pretty wide time span.
Right.
I mean, and that's, that could be by chance.
Yeah.
I mean, I'm just looking for something more scientific, since dating is such a scientific thing. So much has been, we've been discussing is science.
Yeah.
well, I believe that there actually are quite a few archaeological pieces that have been dated all over the world, really. And of course they wouldn't. I mean, from an archaeological standpoint, from an anthropologic standpoint, there wouldn't be, well, and I guess, I would say from a biblical standpoint, you can't really argue too much about, things that are 10,000 years old, but there are archaeological sites like Jericho and Göbekli, the one in Turkey, that are about 10,000 years old. And those have been measured. Reasons to believe would accept those dates.
Sure. But I mean, those that's so broad, I guess is what I'm saying. I mean, and when you look at the Bible and you look where references of people are, hundreds of years old, I mean, and I understand that there's a language disparity there, but I don't know. I just go back to the whole purpose of why we're here. What are the reasons to believe, and how does this relate to it? So I'm just trying to get all the meat out of this I can.
And an example, I mean, for me anyway, and this would be kind of the primary example, is in the beginning, God created the heavens and the earth, which seems to correspond to the Big Bang, and that it takes somebody who is outside of space and time to create a universe out of nothing. How can you explain from a materialistic standpoint the creation of the universe, unless somebody who is outside of space and time was the creator?
Yes, and I agree with that, Kirby. I agree with that, but it goes back to what we were talking on our last session. How do you bind that entity to the God of the Bible?
Prophecy.
I have a somewhat of a comment, if I can. I don't know how to put my hand up on the.
It's all right.
To butt in.
I don't know how to lower mine.
Anyway, so on YouTube, I've seen some really great, archaeological discoveries that go back into, the early parts of the Old Testament and confirm the dates of Joseph. There was a new site. They were going to build a prison or expand a prison, and they found this house church that is dated, if I'm not mistaken, at the end of the 2nd century, where they've got an inscription that basically says that Christ is God. And so that confirms that from the earliest outset, more information, and that, what is the gospel? And so you can find these things that are consistent. So as far as the skeptic or the one that's searching, you can point to these consistencies that are being discovered that confirm what was written in the Bible is so much better than any other religious writings. And so that says something about what the gospel is and what God's message of reconciliation. So I would recommend that you just do biblical archaeology on YouTube, and you'll find some really great resources.
I subscribed to the magazine for a while years ago. Okay.
There's a lot, but Randy, there's a lot of like John was saying, there's a lot of stuff that confirms what we see in Scripture with carbon dates and archaeological investigations.
Is there how much is there that doesn't?
There are some problems and puzzles people are working with, but those are the exception. I mean, the vast majority matches up nicely, and then the few things that don't match up, those are the interesting things to study and figure out why doesn't it match up? What don't we understand here?
And
so
how do they match it up? I mean, because there's not a lot of details in the Bible.
Well,
Marina George had some. Was just mentioning some to me. Marina, could you unmute yourself and mention some of those things that you were telling me about just now? There she is.
Yes. Hey, everyone. Hi, Kirby. Hi, Kirk. And everyone, it's great to be with you guys again. Yes, I was just listing some things there. I posted them in the chat about, those are just a few biblical archaeology discoveries that have been made, and all of those things that I listed, they exactly date back to when the Bible says that they were around, and there's so much more as well. But yeah, biblical archaeology is such a huge field. I've been taking several classes now with Professor Ted Wright from Epic Archaeology in collaboration with the Besora Institute. And for about 2 years now, I've been taking plenty of biblical archaeology classes. And these are just a handful of what is so much more to be said about this topic. But yes, there are plenty of artifacts that we have found that date back to when the Bible says they existed. So I just wanted to make that point. I put some of those things in the chat, but there's so much more than that. But those are some of the things I can list off the top of my head. But yes.
Yeah, I saw that.
If you want this, I haven't read this recently, but if you can see this one, this is a fairly recent book by Jim Hoffmeyer. He's a archaeology professor, was at Wheaton, I think now he's at Trinity. But the archaeology of the Bible. Hoffmeyer is a kind of an Egyptologist. His specialty is Egypt, but he's good. He's scholarly. He's evangelical, and this would be a good one. An older one is Kenneth Kitchen, and Kitchen has written a number of things. He's interesting. He doesn't have a PhD, and he's interesting to read because he gets a bit dismissive of some of the scholarly community. He's out there doing digs, and he kind of gets dismissive of those in the ivory tower, but it makes him fun to read.
You know, it's interesting because I don't have a problem with the history of things and archaeology and the dating itself. It all goes back to me, the link to the metaphysical, the link to God. And obviously that's not really the focus of this discussion. That's where I'm good with that. If there's history out there, and Marina, thank you. Is it Marina or Marina?
Marina, yes.
Marina, yeah. No, and I appreciate that. I just it's and that's great. But again, it's the jump to that which we don't know. Well, some of you know, I guess, but I don't. And but it's that jump to how do you make that leap to that which by definition, if we go back to discussions before, where I found that, and this goes back to the girdle discussion, Kirk, we can never know anything that's above us. We can never understand anything that's above us. So we claim to understand that, yet in the Bible, apologetics claims to understand that, yet without evidence, or without evidence of the metaphysical, that metaphysical link, not the archaeological, not the scientific. I'm good with that, but it's that metaphysical. Okay, I'm done. Thank you.
John, did you have a question? John Woo, you're muted.
I just had a comment there where I was going to say, Randy, oftentimes I think I've heard the other way as well, where skeptics will actually not care about archaeology. And I think their view would be, and so as everybody's pointed out, there's definitely a preponderance of, quite a bit of material, biblical material, like Hezekiah's tunnel. There's all these different inscriptions we have, down to maybe about 1000 BC even. And but I've also heard skeptics say that really, like, even that really wouldn't convince them, because it's not necessarily just because there's proof that Hezekiah was a king that was listed in the Old Testament. It doesn't necessarily do any more for them. I would say for myself, I tend to prefer the more kind of like philosophical perspective, discussions or proofs. And so you may find, if you look up Josh Rasmussen, he kind of goes through this an S5 modal logic on based upon like necessity, and to argue about the greatest, the maximally greatest being that must exist because of his very nature. He must be ase, and so that may be an interesting corridor to go down. So.
John, could you put that in the chat? His name.
Yeah. Yep. Josh Rasmussen. I'll go ahead and type it in there.
And by the way, I don't have a problem. I believe that Jesus existed, but to say that he died and then came back, that's problematic for me. We don't have zombies. But so anyway, I appreciate it, John.
We did do a
Are
talk recently on the resurrection.
But the Jews, sorry, what you're saying, John, about that maximally great being, it's an interesting argument. I believe that's called the ontological argument, and it is very interesting. I'm not sure I fully understand it, but in terms of the resurrection, I mean, the Jews don't believe that Jesus is the Messiah. They think he was just a man, but Jews believe in the resurrection. So there is a connection there that it's in Maimonides, who's a medieval great Jewish philosopher and Bible commentator, said that he wrote 13 articles of the Jewish faith, what Jews believe, and the last one is the belief in the resurrection of the dead. And then you have this. So the concept is there. Jesus didn't just, first Christians didn't just pull this out of thin air. And also Jesus rose on the Feast of First Fruits. If you go back to the story of the Exodus story that Moses wrote down hundreds of years before Jesus, you've got the Passover, the Feast of Unleavened Bread, and the First Fruits. And the theologians have dated the morning of the resurrection to exactly when the rabbis were waving the sheaf offering of wheat in to celebrate the Feast of First Fruits. So when they were saying, "Look, the first fruits," Jesus was rising from the dead. So first fruits meaning he was the first one to be resurrected. With the rest of us have to wait until.
Oh, wait a minute though. Not all of us had to wait, right? I mean, in the Bible, it states that after Jesus rose, didn't other people rise from the dead?
That's no, that's not a resurrection. That's a resuscitation. Lazarus was resuscitated. To be dead and be brought back to life and only to die again is not a resurrection. Resurrection means you get an incorruptible body that lives forever. Totally different.
Oh, I'll have to try to get my arms around that one.
What did you say, Kirk?
So Ari's saying the resurrection involves a new resurrection body, not the old body. So that's right. That's the distinction he's making there.
And right. I think there's even a mention in the New Testament about Lazarus or someone who was resurrected but died still, and and there's a difference between him and Jesus, but I don't remember where.
But Azari, are you saying that you said resuscitated, but they were dead?
No, they died. They died later.
But they also died. I mean, Lazarus was dead and he was buried, and Jesus called him forth, and he was alive again. But what Ari is saying, I think, is that's not what the resurrection means in terms of the ultimate resurrection that the Jew would, or the Jewish faith would talk about. Is that what I understood?
Right. The resurrection that the Jews, that Maimonides and Orthodox Jews believe in, is that everybody will be resurrected. Yeah, as Daniel says, some to, how does he put it? Some to everlasting shame and contempt or something, and some to everlasting blessing or something. Glory. I forget. Pardon me for getting the quote wrong, but it's one of the last verses in Daniel.
Sorry.
And many other, David in the Psalms writes about, "I will dwell in the house of the Lord forever, and thou wilt not abandon my soul to Sheol," which is the grave. So yeah, there's a strong case to be made, and uh, Yom Kippur, Day of Atonement, the Jews greet one another saying, "May you be inscribed in the book of life," and the book of life is everybody's name who will be in the Olam Haba. That means the world to come. The world to come is not this world; it's the next world. It's when people will be resurrected to a totally different life. They won't have the same bodies that they have now. It'll be a future age.
Well, it's this kind of confusion and if this is complicated, and it's this sort of confusion and complication that breeds for me skepticism, because if God wanted it to be clear, this isn't clear.
Sure it is. Well, I don't know what your confusion is. Just look into it a little more.
Look into what, Ari? Ask, tell Randy specifically.
Yeah, I mean, in other words, to die and then be brought back to life in the same body, but just overcoming the death experience through a miracle, right? If you believe in miracles.
No.
Well, no, if somebody, but there's for those who do, you understand the concept of a miracle at least. You don't have to believe in it, but you understand the concept of a miracle, changing water into wine. Okay, so given that the concept of a miracle is understood, then for somebody to die and then to live again, but basically to come back as the same person and then grow old and then die again when he's old or comes down with a disease, dies of old age or so forth, or disease, that's another concept that is easily understood, right? So that's on the one hand, that's what I call a resuscitation or a miraculous coming back to life, but it's not a resurrection, because resurrection means that everybody that died will be brought back to life when Jesus at the end of the age, when history is drawn to a close, and all there is a new heavens and new earth, and people are in either heaven or hell. In order for people to live forever, when Jesus said, "I'll give you eternal life," they have to have a body that's incorruptible. Paul talks about this. That this happens at the rapture. We will all be changed in the twinkling of an eye, and we'll put off corruptibility and put on incorruptibility. So that's just a concept. Now it may seem far-fetched, of course, but I think it should be fairly easy to understand the conceptual difference between God raising up everybody into giving them a new body that will last forever, either in heaven or hell, and contrasting that with what I said before, the former method of just coming back to life and then growing old and dying a regular death like everybody does.
Sure. I just think that evidence is more powerful than faith. And I mean, we've seen, like Kirk laid out today, how radioactive dating, how the different forms of dating have evolved to a point where we're much more precise, much more much more accurate than when it was originally. And I believe human thought does that as well. And that's why I can't make that jump. I cannot make that just jump of faith that someone died, and wasn't and was raised in a forever, forget the term you used, but in a state that's not something of this world.
Can I make a comment?
Yeah.
Can I make a comment? Recently there have been thousands of near-death experience. You heard of this near-death experience, right? People who similarly die and physician confirm there's no pulse, no heart rate, no brain activity, and they come back.
My brother and my wife are two of them.
Yeah, and I've been physician. I've seen and witnessed 7 of them in my lifetime career. So you have seen that, and there's a difference between a soul and a body, if that's so, right? So this is a concept that people maybe decades ago would not believe it. Do we really have a soul? But because of the recent thousands of evidences, the scientific community have been scrambling their head trying to explain that.
Well, and
So,
I've been consistent about saying that it's not that I don't believe that there's something out there. It's not that I don't believe that maybe there is some creator out there that gave rise to all this.
yes.
It's how it's which ancient text, if any, or maybe it's something completely different than that.
Well, yeah. Well, that's why we have a bunch of apologetic material to prove which religion is correct. So since you already believe a soul and a body is different, and now to the second point,
well, no,
our dear friend Ari had mentioned resuscitation. That's basically a non-material change in our body composition. It's like change from water to wine. The difference is there is carbon there. Water does not have a carbon. Water H2O. The wine has carbon in there. Now, when we are resurrected, we have a completely different body, and that is not the same thing as resuscitation. So you say you cannot grab all the ideas, and that's what we are here for. And part of apologetic is to study Jesus' resurrection, and that's true. Like Paul said, if there's no resurrection, then whatever we preach, whatever we hope for is hopeless. There's nothing else to say.
It sounds to me, Randy, it sounds like you're looking for absolute proof of these events. And I don't think that we can provide absolute proof. We can only prove that we believe what we have said.
Well,
I believe what I've said.
Obviously,
and I cannot prove it. I cannot prove it. At some point, you have to take it on faith.
Yes, we can't even have absolute proof in science. I mean, we don't have absolute proof that the law of gravity works.
And that's
we have
why
all kinds of tests that it does, and we have verifications, but it's not absolute proof.
And that's why I've always never claimed that it did. I mean, I've always claimed it's always a matter of probability. And that probability, it goes back to Kirk, that Feynman's chessboard. You're looking at a quarter of the board, and you don't know how the rest of the game is played, other than that little piece of the board that you're witnessing. And so I'm skeptical, and I just can't cross that line because it seems so limiting.
I understand your skepticism, actually. And I'll very briefly tell you my own story. My own story is that I was an atheist, closet atheist, until I was 35 years old, even though I always went to church. And ever since I was about a teenager, I went to church regularly on a regular basis. And I wanted to believe, I just didn't. And I sang in the choir. I'm a church soloist, so I sang solos in church. I became a deacon in a church. I was teaching a Sunday school class in Hawaii. And during the class, I knew that this particular woman who was in the class was a very strong believer in Christ. And here I'm teaching the class and I didn't believe. And this woman said, it's okay to have doubts. All Christians have doubts. It's okay to have doubts. And that was like a curtain came over my head that was pulled over my head. And I said, it's okay to have doubts. I believe. All of a sudden, that's all it took for me to go from a skeptic like you to belief. So, I just pray, Randy, that you will have an experience like that at some point in your life. And I hope it will be sooner rather than later.
Well,
meanwhile, I really think we need to stop this meeting.
Doug's got a hand up.
Oh, okay. All right. So who's got a hand up?
Doug.
Just a very quick comment.
Okay.
Kirby, I'm not sure how you're archiving these talks, but about a year ago, maybe could be as much as a year and a half ago, I did give a talk on this forum on a historical argument for the resurrection. That might be worth looking at, and you can decide. It's ultimately a historic argument whether or not Jesus rose from the dead, and I try to present that argument in that presentation. If you have an archive somewhere, maybe you can.
Well, yeah, we do have an archive, but that's, at some point we started it, and it may or may not be online, or I'll look for it, and I'll publish that. I'll publish it if that's the case.
It's definitely on YouTube. I still see it there, so it's
okay.
on YouTube.
All right.
And so if you Google Doug Kyle, the case for the resurrection, I think of Jesus, you can have a look at it, and you can decide whether it makes sense or not.
Yeah, and I look at both sides, Doug. Just so you know, I mean, because there's arguments on both sides, and to me, that's a general problem. The fact that God is not clear, the fact that God relies on faith and doesn't want to know me directly, that I have to suspend my belief or suspend my reason to believe.
God does want to know you directly, but anyway, Marina has her hand up, and I'd like to hear what she has to say.
Thank you, guys.
Yeah. Yes, thank you. I just wanted to make a quick comment about one of those methods we were talking about earlier today, the Shroud of Turin. Yeah, I think it was X-ray scattering, if that's right, Kirk. But,
it might be, yeah.
Yeah, the one that you need to know the temperature of. But there was a pretty recent study done by the Institute of Crystallography of the National Research Council. And when they were doing this X-ray scattering, they had to estimate that the shroud was that the temperature that the shroud was that they kept the shroud in was around room temperature. And when they did that, it does date back to around the time of Jesus. In order for it to date to the medieval times, it would have had to have been an extremely high temperature, which would be unlikely. So I just wanted to bring that point up, and also about the blood, how they discovered that really is blood, and it of a crucified victim as well. And there's several other things about this, but I just think that I actually personally believe that the Shroud of Turin dates back to Jesus' time, and it is the burial shroud of Jesus. But I know there's a lot of other things to say about this as well, but I just wanted to bring that point up. But thank you again, Kirk, for the great presentation.
Yeah, I think I mentioned some of that these thermochemical techniques depend on knowing the temperature. And if the temperature had gotten very hot, even for a few hours, it could throw these things off. So if the shroud had survived a fire, which we know it did, that could have accelerated a lot of these dates. And I know the shroud is somewhat controversial, but I will briefly tell you what I think the shroud is. I heard a good talk just before the date was done at a radiocarbon conference. They had a guest speaker who was an archaeologist from Canada. And not an archaeologist, an art historian. And he had looked at it from an artistic perspective. And he concluded that this was an art object. And so many of the things just didn't quite match a real human. And every one of the things that we see in scripture that happened to Christ was shown there. The spear in the side and the crown of thorns, and all the different things were there. So his conclusion was that this was an art object made by the medieval church for worship. That they would hang it up during Holy Week and remember all the things, that Christ had gone through. And then when Constantinople was sacked and all of this, they kind of lost the history of it. And people then found it and thought it was a relic. But I kind of like his theory that it was not made as a fake, and neither was it a relic, but it was made as an art object to remember Christ at Passover week.
Like the Stations of the Cross.
Yeah, that kind of thing. Yeah.
And that's a perfect example of what I was talking about. That is something that is kind of, at first, a lot of people believed. I wanted to believe it. I remember when I first read about it. And yet, that's a reasonable explanation for it.
Yeah.
So, I mean, I just kind of extrapolate that.
Okay, well, I really think we need to wrap things up, and I'm going to ask Kirk to close this meeting with a word of prayer.
All right. Lord, we thank you for the chance to discuss these things tonight. Thank you for the amazing things you've placed in your creation that help us to use it, use some of these techniques to figure out what happened in the past, how you created some of these volcanic mountains, various things in our history. And we just thank you for all of the richness that you've built into your creation for us to find. In your name, amen.
Amen. Well, thank you, everybody. I see my camera fades in and out. I don't know what's going on, but
Thanks a lot, y'all.
Karen and I will stay.
Have a good one.
Karen and I will stay for a
Thank
little
you,
while
Kirk.
if anybody wants to
Thanks.
continue to talk. So, but thank you all for coming anyway. And I'm going to stop recording now.
And thank you. Bye. Bye-bye.
Thank you very much.